Okay, let's calculate this matrix inverse. So there are a couple of different ways to actually calculate a matrix inverse. But if you're doing this by hand, the best way to do it is to use an augmented matrix. So what I'm going to do is I'm going to take our matrix, and I'm going to augment it with an identity matrix of the same size. So what I've done here is taken our matrix, augmented it with an identity matrix, and what I'm going to do is I'm going to perform row operations to reduce our matrix down to an identity matrix. But I'm going to apply all of those same row operations to the identity side of this, such that when I finally do reduce my side, or my left side here, down to the identity matrix, the other side, what I'm going to have left over, is going to be the inverse of M. So let's have a look here. Let's go through some row operations. The first thing I'm going to do is I'm going to take the first row, and I'm going to say my new first row is going to be equal to my old first row minus the second row. So if I do that, I get -4 minus -5, I get 1. 1 minus -4 is 5. And the bottom row stays the same. But I'm going to do all of the same things to the right side of the augmented matrix. 1 minus 0 is 1. 0 minus 1 is -1. And the bottom row stays the same. Okay, next what I'm going to do is I'm going to take the second row, and I'm going to say my new second row is equal to my old second row plus 5 times the first row. So that I get, and like I said before, the top row is going to stay the same because we're not doing anything into it right now. And the bottom row, like I said, is going to be equal to the second row plus 5 times the first row. So -5 plus 5 times 1 is 0. -4 plus 5 times 5 is 21. 0 plus 5 times 1 is 5. And 1 plus 5 times -1 is just -4. So now what I'm going to do is I'm going to take the second row again, but this time I'm going to divide it by 21. And again, what we get for the first row, like I said, it stays the same. And the bottom row is going to be 0, 1, 5 21sts, -4 21sts. Okay. And now finally what I'm going to want to do is take the first row, so that the new first row is going to be equal to the old first row minus 5 times the second row. So that 5 minus 5 times 1 is equal to 0. So 1 minus, so the second row stays the same. Uh, 1 minus 5 times 0 is still 1. 5 minus 5 times 0 is 0. 1 minus 5 times 5 21sts, that's 21 21sts, minus 5 times 5 21sts. So 21 minus 25, that's -4 21sts. This is the part where matrix manipulations can get a little tricky. If you make a little arithmetic mistake, it can cascade through the entire problem. So be real careful when you're actually doing your math, because this is one you can screw up pretty quickly if you're not careful. And then -1 minus 5 times -4 21sts, that's -21 21sts, minus 5 times -4 21sts, that's -21 plus 20, so that's -1 21sts. So look, on the left side we've got the identity matrix, and on the right side here what we've got is, I'm going to factor out that denominator, so we get 1/21st, and this becomes -4, -1, 5, and -4. And we're going to say that that is equal to m inverse -1. And you can check this by multiplying this answer with our original matrix M, which should give you the identity matrix. Or you could do it the other way around. In the case of a matrix and its inverse, it is commutative. Although, generally speaking, when you're multiplying matrices, that's not generally the case. But here it is. And this is how you check to make sure that you actually have the inverse of the original matrix.